Hello everyone, welcome back to our channel Easy Peasy Robotics. Today we will explain what is robot operating system, that is ROS. Particularly we will discuss what is ROS, why are robots built using ROS, how does ROS actually work, and lastly benefits of using ROS. And before moving forward, do not forget to subscribe the channel, like the video and share it. Now let us see what is ROS. ROS stands for Robot Operating System, but actually it is not an operating system, but it is a meta operating system that includes a middleware soup. Now, what is a meta operating system? Meta operating system is something that operates on top of an existing operating system and it provides certain operating system features. And as far as ROS, it operates on existing operating system, that is Linux, and it provides essential operating system features like package management, hardware abstraction, process management, and device drivers. Now, ROS can be defined as a set of frameworks, that is including libraries and tools designed for robotic software development, which is used for developing the robots. It enables researchers, industries, and developers to build, share, and reuse the code across various robotic platforms. Now the robots are difficult to build because they have a lot of components all together and all of those components has to work together to make the robot work. Now the robots come in various shapes and sizes, but they share 5 essential components. They are: first is the body, that is the external body of the system, that is the skeleton of the robot. The second is the sensors such as camera, LiDAR to read the environment around it, and the battery that powers the robots, and the actuators that move the robots, which can also be the motors which move the components of the robots, and lastly software system, which is the brain of the robot, which reads the data from the sensors and give the command to the actuators to act based on the circumstances. So when all of these components work together seamlessly, then the robot can perform the task effectively. And that's where ROS comes. So ROS defines these components, interfaces, and tools for building these advanced robots. And ROS also helps developers quickly build these components and easily connect them using ROS tools. And ROS also provides micro ROS, that is a variant of ROS that runs on microcontrollers for real-time performance on those robots. Now, what robots are built using ROS? Well, the answer is almost all the robots are built using ROS, from small startups to big organizations, research labs, and government agencies. And all the different kinds of robots are also built using ROS, such as research and educational robots, autonomous robots, and drones, industrial robots, humanoid robots, underwater robots, medical robots, agricultural robots, and service robots. All the kinds of robots can be developed using ROS. Now, to understand exactly why ROS was developed, it is important to know what was the problem faced so that they had to develop ROS. ROS was developed to address the main problem, that is reinventing the wheel situation in robotics, which means when they had two robots and one program was working on one robot, and to complete the same task using another robot, they had to build everything from scratch for that specific robot. That's the way they were reinventing the wheel again and again for each robot, which was not a good practice. Therefore, then ROS was started as a personal project of Keenan and Eric at Stanford University in 2007. The primary concerns they had was excessive time was spent on re-implementing the software infrastructure to build robotic algorithms for sensor drivers and communication between them. And the second was too little time was spent developing intelligent robots based on that infrastructure. And the actual data from Keenan and Eric was provided, so it shows that most of the organizations at that time were spending most of the time on reinventing the wheel rather than new research. So that was a major concern, which has been beautifully showed by this slide. ROS was developed as a framework that allows the processes to communicate with each other, plus some additional tools to help to create code on top of that. That was the main intuition behind that. And the first distribution of ROS was released in 2009. ROS framework allows to focus more on new research rather than reinventing the wheel. That was the main reason why ROS was developed at the first place. ROS was not the only framework available for robotic development. At that time, some other good frameworks were also available, such as URBI, OpenR, Player Storage, etc. But the reason why those frameworks fell behind ROS was two, that is, they were not open source and they lacked the community support. And ROS at that time succeeded over other frameworks because it was free, that is open source, and it fostered a strong community. Now let us understand how ROS actually work. So the basic building block of ROS are nodes which act as modules. We can see over here, for sensor there will be one node, and for data processing there will be another node, and many more nodes for each specific task. And to ensure the communication between these nodes, they use DDS for communication, that is data distribution service, for secure communication between the nodes. And to transfer the message from one node to another node, they use the message and the topic combination, so that only the necessary information should be transferred, and both can only communicate when the topic is the same. One of the best thing about ROS is it is a language agnostic, that is, one node can be written in Python, another node can be written in C++, still they will communicate well and they will work exactly as they should work if they were written in the same programming language. And they have available packages which are reusable across different robots with a minimal modification. ROS uses a distributed computing architecture, that is, it uses a graph-like structure where nodes act as individual modules and they communicate with each other. If you see this graph, we can see that this is an example of a robot where we have a camera, LiDAR and GPS which will be taken as a node. All the information will be taken by this node. Only the necessary information will be shared with the data process, which will then use this data and to do some other task and forward only the necessary information using topics to perception node, planning and localization node. Then it will give the commands to the actuator node, which will make the robot move. So that is how the graph approach works. Three major important features of ROS: Rosbag, RViz and Gazebo. Rosbag is used to easily record and use this recorded data offline for processing and experimentation, so that you do not have to do the experiments again and again and do the experiment once and use the data to do further processing offline. The another big feature is the digital twins, which helps to simulate the robots and their movements using tools such as Gazebo, which is a simulator. So the robot that we have in real life can be simulated in the simulation and all the experimentation can be performed in the simulation, hence not even affecting the hardware of the robot. And it also provides the hardware support. We can use cameras, lidars and motor controllers in this simulation, and we can exactly mimic the movement of the real world in the simulation, and the final product can be deployed on the real robot. The third is RViz, which offers a visualization tool for the robots and its features, and it also enables robot testing without the need for physical hardware. We can see over here, with this robot we can visualize a lot of things with that. We can see the direction of the robot, we can see the point cloud. Over here we can see how the robot is perceiving the world and how it is reacting. That's how the visualization tool helps to understand what exactly the robot is seeing and can act accordingly. Now the benefits of using ROS is that it is open source and it provides a modularity and a reusability of the system, and it has a distributed architecture like graph, and it provides simulation and visualization tools, and it has community support and collaboration, which is a big plus for ROS, and scalability and adaptability and integration with various robotic hardware systems such as camera, lidar and many more to work with. So finally, we can say that ROS enhances the development efficiency, reduces the cost of development, and provides strong community support. And ROS helps focusing on new inventions rather than reinventing the wheel. That was the main purpose of developing ROS, and which is being used. And finally, thank you for watching the video.